Today we're going to look at the discriminant. So the discriminant is actually a component of the quadratic formula. So let's just remember that the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. So this part here circled in blue, this is the discriminant. And by using the discriminant, we can determine the number and type of solutions to a quadratic equation. So we're going to be looking at the 3 different possible cases here. Now, case 1 is when b squared minus 4ac is greater than 0. In this case, we end up with 2 real roots, and remember, roots is another word for solutions. So we can see that we have 2 of them, and the type is that they are real. Case 2, when we have b squared minus 4 times a times c is equal to 0, this gives us 1 real root. And some people refer to this as 2 identical roots. For case 3, we have b squared minus 4ac is less than 0. And in this case, we have no real roots. And some people refer to this as having imaginary solutions. And in this case, you would get 2 imaginary solutions, or roots. And if you haven't learned about imaginary numbers, then don't worry about that. So let's get on with some examples. Our first example for working with the discriminant is going to have 3 different components. And for each, we're going to be determining how many solutions each equation has and what type of solutions they have. So our first equation is 3x squared minus 7x plus 10 is equal to 0. And the discriminant is b squared minus 4 times a times c. So we are going to substitute in negative 7 for b, 3 for a, and 10 for c. And then we're going to evaluate. So negative 7 squared gives us 49. And 4 times 3 times 10 gives us 120. So we end up with 49 minus 120. And this gives us negative 71. So in this case, we have no real solutions or no real roots because the discriminant is negative. So therefore, no real roots, also referred to as solutions, because the discriminant is negative. And if you are picturing a parabola, this is a parabola that does not have any x-intercepts. Let's go to another equation. So for part B, we have x squared plus 4x minus 1 is equal to 0. And again, we are going to write down and then use the discriminant. So b is 4, so we have 4 squared. A is 1, and c is negative 1. So we end up with 16 plus 4, right? Because negative 4 times positive 1 times negative 1 gives us a positive 4. And this gives us 20. So in this case, our discriminant is positive, and this means we have 2 real solutions. So therefore, there are 2 real roots, or you can use the word solutions. And this is because the discriminant is positive. Okay, let's do another one. And this is part C of number 1 example. So this is our last one for this part. So our equation is x squared minus 12x plus 36 is equal to 0. And again, the discriminant is b squared minus 4 times a times c. b is negative 12, so we end up with negative 12 squared minus 4 times 1 times 36. Negative 12 squared gives us 144, and 4 times 1 times 36, or negative 4 times 1 times 36 gives us negative 144. So we have 144 minus 144, that gives us 0. And in this case, there is only one real root because the discriminant equals 0. Example 2 of the discriminant lesson. For what values of a does a times x squared plus 5x minus 3 equal to 0 have one real root, two real roots, and no real roots? So we're going to have to do a lot of work for the first part, but then we're going to be able to use part of our answer to answer parts B and C. So when we have one real root, this means that our discriminant is equal to 0. So let's put in the information we do know. We don't know what a is, but we know what b is. So b is 5, so we end up with 5 squared minus 4 times a, and then c is negative 3, and that is equal to 0. So that gives us 25 plus 12 times a is equal to 0. And now we're going to solve for a. So 12a is equal to negative 25, and a is equal to negative 25 over 12. So this tells us that when a is equal to negative 25 over 12, the equation above has one real root. So now that we figured that out, we can use that information that we have right here of a being equal to negative 25 over 12 to answer parts B and C. So remember that to have two real roots, our discriminant must be greater than 0. And if you look up at part 1, we made it equal to 0. So we can then concur from this that a must be greater than negative 25 over 12 in order for the equation to have two real roots. And for the equation for part C to have no real roots, b squared minus 4 times a times c must be less than 0. And so this means that a must be less than negative 25 over 12.